Now we need to implement our define our class or attribute actually. Public class performance and attribute. Put a postfix attribute because it's a simple attribute. So we inherit our attribute from the I method decorator. So we need to implement our interface. As you can see, we have some methods that uh, hooked our probable invocation method. So I need an attribute in order to put our attribute in top of our method, and whenever our method in invoke, first of all, before invocation, it's getting to on init or init. It's this method get some information about the method that's currently executed, and give some information about the instance. Uh, Instance means the runtime parameters may get, or runtime information about the method. The method base has some information about the method, what's its name, what it, for example, properties may use, or parameters actually, even using the parameters. I did give some good information about the method that is currently executed here. So I need an attribute usage and say attribute target dot method. That's enough, and inherit it from the attribute. It's quite enough to working on it. And for test, we can say console dot write line method invocation initialized. This is the initialization. As I mentioned earlier, before invocation, the method, before getting inside the body of the target method, the init method will be invoked and do what it's on its body, and that's the end. So it's better to adding some information about the method, target method actually. So say method dot name. That's enough. We don't need the on entry. Some exception may happen. We'll try it. So we console it and say some exception occurred here. And on exit, we notify that method invocation just end. Method invocation just end. That's it. So this is all I want to implement our attribute to benchmarking our project. So it's good to make it a bit closer to the real world scenario may happen in your projects, and you may need to do that. I prefer to adding a property for actually I need it as a performance. I implement the property stopwatch, and it's better to be private. We don't need outside here. It's W, and we start the stopwatch here, and the exception. How can I make it pretty, a bit pretty message? So exception invocation happened and at. So this is what I need here, and say sw dot slaps milliseconds. And what I need here is to adding a lapse millisecond. So we need to stop the stopwatch here. I forget to stop it here, and do the same for unexit, and just end at adding a lapse millisecond. Oh, do it wrong. So put the dollar sign at the start point of the string, and w dot lapse milliseconds. So that's the end. I think that's enough to show the wonderful features of this method decorator. As, uh, as I said, it's pretty simple and easy to use. Uh, and it can be a drawback of the method decorator because it doesn't give you more option to manipulate your methods as well as you want. So I create a static class, sample class, and makes make this class static because or not. This is not important to make this static. So say public void invoke method console right line. This is just a sample method. Now I need to put the performance attribute on top of our method. So this is quite enough. And what I need to do is removing namespace curly braces in order to make more code are more cleaner. So where's sample obj? We have sample obj here, new sample class. Yeah, this is okay. And sample obj dot invoke method. That's it, and we need to run our project to see the results. Before running our project, we need something to explain. Uh, as soon as you add a method decorator project to your project, uh, first you need to, before add the method decorator, you need to add a Fody. This is requirement. This is what you actually need to work with Fody packages. After that, you need to register uh, the sub packages of the Fody here. For example, I'm using the method decorator here. I registered as a sub package of the Fody and tell to the Fody I'm using the method decorator, and that's it. I need to rebuild my project. It's great. Now I'm going to run my project here using the so as you can see here, our method uh, our attribute methods uh, invoked executed actually, and our real invocation method is executed either, and there's a problem with the stopwatch. I will check it out to see what's happened there. But for better look, we can put it some breakpoint to our attribute um, methods to see what's going on here. So I think there is a problem with the stopwatch here, and say I don't know. We will check it out to see what's happened here. And I explain about some other scenarios you probably need to know about them, and the problem with this kind of programming we may have in real world scenarios. So I need to run it again to see what's going on here. No, we need to stop it off. So I put a breakpoint on the invoke method and put the breakpoint on every single method I implement here from iMethodDecorator. So as you see, the invoke method started off, but it doesn't go getting inside to the method body. It first getting to dive into the init method. It execute the init method, start this off, and uh, continue execution, and going on top side and of the exit method, and stop it and terminate the method. This is it. So we have a problem with the stopwatch. This is not kind of problem here. I can make the stopwatch here. This is not our problem. This is okay, I think. This is not a problem and big challenge for us. We can continue this way. So we started again to see what's happened. As you see, it starts to invocation, but redirecting to init method. First execute the init and uh, execute the real method, target method actually. Now it stopwatch work correctly and method execute successfully and terminate the method successfully. And as you seen here, we have a console messages here, and that's it. But we have some constraint in real world projects. Uh, your target projects probably have some layers. You may benchmarking your entity framework or unit of work methods, or your service layer. You have some benchmarking on service layer. This is a problem, and this is a problem, yeah. But what's the problem? The problem is you have to add the method decorator in every layer. You need to benchmarking their um, layer methods. The solution for me was adding a nugget package itself for myself and add to Fody and MethodDecorator.Fody to that. And as the Fody website project said, add a module uh, on the above up the namespace and the DLL automatically added the code of your performance attribute or whatever you called it, and you can use your um, attribute or whatever benchmarking attribute you want to use in your every layer you want to. So what's the problem with this is why we, and this is the constraint what I'm talking about. And the reason of why this happened is because uh, it happened on runtime and everything in runtime. And when you um, inject it just as a reference, it cannot access to your runtime object values. It just can't see the properties, can't see the classes, their names, and cannot access to your method invocation statuses as a init or an exit or an exception or something like that. So we need to add your code. Uh, we need to add our code to our runtime and to our DLL. This is can be happen with a module and assembly that is maybe you rarely seen in your codes and projects. But if you want to benchmarking your methods with this kind of way, you have to use the module in every layer you want to use. And actually, you need to install the Fody and method decorator to Fody in every layer of the project you want to use. This is important, and you have to notice about it. So get back to our project and check it out. Uh, I need a class library here. So what I need here is to add a class library here. That new class lib.n sample, or maybe uh, what I have to do? Okay, benchmark layer. This is simple. This is a sample and simple. So, okay, our class library ready to use. So we need to delete our Fody and method decorator Fody from our project console application. So need to we need to delete these packages from CSproj and go to the benchmark CSproj, and as you can see here, it throwing error to a console application, and uh, better to add some SLN file. Let me just some time to add SLN. I will get back to you to continue the video. So I rather to continue with video to adding SLN and adding SLN project.net SLN add, and yeah, this is it. Okay, we added the benchmark layer to SLN and the other one SLN add. No, this is not what we're looking for. No. Okay, we added the project CSproj to SLN. So this is make me easier to build all over the layers. So .NET build to building all layers on the same ons. So as you see here, it generates the Fody behaviors on the sample project. That is not true. So benchmark layer, let me just sometime to get back to you. So the problem is solved. The problem was we add the benchmark layer in the same root as the project layer exists, and this is kind of problem for Fody and method decorator Fody in order to choose a target assembly, and we have now we solve the problem, and I remove the project and new another one with the same name and put it on the project folder and add it again at SLN and makes it a new, and add the projects to the SLN file, and whenever I build this it's pretty straightforward and build it success all the projects subsequently the project. So now I added the method decorator and Fody to the benchmark layer, and I want to use the method decorator performance attribute from the benchmark layer to another target project, which is sample class and performance. So before using this attribute, we need to add it a reference. So we project, we added a reference benchmark layer. This is the way I'm using adding reference from command, and the benchmark layer added to project layer. Now I can't added a performance attribute using performance. So we add our performance attribute from the benchmark layer to our invocation lifecycle and added the executing the project once to see what's happened here. Throwing error, no problem. We can get into .NET Run and see what's going on here. As you can see, it's just uh, writing the own invoke method message and don't affect the method inside the performance attribute. Why? What's the problem? As I mentioned earlier, if you want to using method decorator features in another layer of your projects, you need to add module. Why this happen? You need to add the code to the runtime of the target project, and this is the way that you can deal with that. So we add the module on the bow of the namespace, adding module, and set it the name of performance, and it's throwing an error to me, and I get back to the attribute and say add attribute target to module, and actually it's all the error gone, and .NET Run again. As you can see, there's a invoke method message. Get back to our performance attribute and added the module to the own performance and set it a name to it and run it again. So let me check this out to see what's going on here. Okay, so if I run it again, oh, it's just happened. Let me get back to the video and check it out what's happened here. So I had a problem with adding the Fody and MethodDecorator to the target project. As I mentioned earlier, this is the two requirements to working with Fody and MethodDecorator.Fody. The first one is adding the Fody and MethodDecorator.Fody to the target project. This is so important in order to working with this kind of programming for benchmarking or something like that. And the second one is adding the module keyword and attribute to one of your class. Put put it up, put it on the top of the namespace, and whenever you do that, when you build and run your project, uh, the performance codes will add it to the DLL of the every layer you targeting at. And as you can see on the console, we see the invoke method invocation initialization message, which is came from the init method of the iMethodDecorator. We check it out again to see what's happened here. So performance attribute from the benchmark layer and as you can see the init method. We can also if I put a breakpoint on here. We can see what's going on here. If the breakpoint work, it's great. It will be great. But I don't. I'm not sure about. Okay, it's working. So as you can see, we have some information about method. As I mentioned earlier, is the method.name, which is invoke method, and some arguments. In this case, our method has no arguments, and you can work with that. It's working on runtime, so you can access to their argument values. This is interesting for everyone who log the method arguments. It can be interesting for someone who may would like to log it off. So after initializing, the body of the method will be executed, and at the end of that, the exit or method termination will worked. And as you see here, method executed, and on exit method executed, and the invoke will end. So this is how you can use to performance every method of your project. It can be a good feature to log your method performance. It can help you to um, optimize your code quality, because it's benchmarking your method with which benchmark is slower than others and which one is need to optimize. uh wish this video will helpful for you. I will be recorded some new videos in .NET and C# in the close future for you, but for now this is the end. Glad to record a new video for you, and have a good time. Goodbye.